All right, in this unit, we're going to define what an isotope is and how to calculate average isotopic. First things first, copy down the definition of what an isotope is. You also need to know how to define an isotope in terms of the atomic number and the mass number, as well as the subatomic particles, the protons and the neutrons. Isotopes have the same atomic number or the same number of protons, but each one has a different number of neutrons. Look carefully at my example here. Look at these three isotopes. The one all the way to the left is carbon-12. It's got 6 protons and 6 neutrons. The middle isotope has the same 6 protons but 7 neutrons, and this one has 6 protons and 8 neutrons. Each isotope has a different mass based on different numbers of neutrons. When we write the notation for each of these isotopes, we can use both the atomic number and the mass number. As you see down here, the atomic number 6 for all three, because they're all carbon, but they each have a different mass number. Because the mass is the only thing that's different, we could also write the notation like this: carbon-12, carbon-13, or carbon-14. It's not necessary to include the atomic number all the time. Some isotopes are more abundant than others because they're more common. Look over here. Carbon-12 is the most common isotope of all the carbons, and it's the most abundant. When we take the weighted average, taking into account the percent abundance, the average should fall closest to the whole number 12. Problem. Here's the formula, the generic formula for calculating average isotopic mass. First, you would look at the mass of the first isotope. In this case, 34.97 is the mass of our first isotope, and we'd multiply it by the abundance. But we don't want to use the abundance here. We want to use the fractional abundance. Then we would add the mass of the second isotope multiplied by its fractional abundance. If we had more than 2 isotopes, we would continue the pattern. We would do mass of each isotope by its fractional abundance. So write this information down in your notebook and practice setting up the problem to solve. While you're doing that, I'm going to solve it with you. And let's see if you get the same answer as I do. So we have 34.97 times 0.7567. That product works out to this, 26.49. Now I rounded to 4 significant figures based on the rules that we've set up in the last unit. The second product will be 36.97. That's the mass of the second isotope times its percent abundance. Now this percent abundance is much smaller. So this particular isotope is going to make up a smaller fraction of the average, only 8.962. If I then add together those two fractions, I get the average of 35.45. And I rounded it to 2 places beyond the decimal based on the rules of adding with significant figures. Here's another practice problem. Take a moment to write down all the information in your notebook. Remember to use the AMU that is given for each of the isotopes, and don't forget to turn the percent abundance into fractional abundance. Now, just as an aside, I want you to think about, before we get started, where the average should fall. We have gallium-69 and gallium-71. Gallium-69 was the more abundant isotope. Gallium-71 was less abundant. The average should fall somewhere between these two, But it should fall, if this is 70 right in the middle, the average should fall closer to the 69 because it's the more abundant isotope. So let's do the math together. We have the first isotopic mass multiplied by the fractional abundance, and that product is 41.43. The second isotope multiplied by its percent abundance, and that product is there. Then we add those two pieces together. And the average is 69.72. As we said, it would fall closer to the 69 than the 71, and it did. Here's a final practice calculation. This particular one has 4 isotopes, so we're going to have to average 4 products together. So take a moment to copy down the information in your notebook and check your calculations against my work. Now, sometimes on the regions they'll write, instead of the fractional abundance, they'll actually show the percent, and they will show that it is divided by 100. So sometimes you'll see that on a region-style question. We could do 0.9493, or we could show 94.93 divided by 100. When you have a percent this small, sometimes students will turn 4.29% and they'll just move the decimal one place to the left. And if you wrote 0.429, if you wrote this, that's really 42.9%. So you have to be really careful to make sure you move that decimal 2 places to the left. Were you careful on that last percentage? All right. When everything is said and done, all those different products, what I had was 30.35 was the first product, 0.25, 1.46, and 0.007. And if you add together all 4 pieces, the average is 32.07, which should make sense because the most abundant isotope was this one right here, the 32. So our average should have come close to that because it's 94% abundant. And that makes sense. Our average did come closest to 32. And there we go. So when you get into class, you'll do some more practice problems.